All right, we're going to do C3 because C3 is one of the ones that asks you to do it both mathematically and using array diagram. So that's the one we're going to do. Okay, so it says a convex. And remember, when you're taking the test and you're doing an FRQ, does it make a difference what type of mirror it is, whether it's convex or concave? Of course it does. So I would just write that down as a reminder so you don't make a mistake and think it's the other type. So it says a convex mirror of focal length 33. So F is equal to 33 centimeters. Now remember, with convex, when I draw my principal axis, this is on the other side. So this is going to be negative 33. Forms an image of a soda bottle a distance 19 centimeters behind the mirror. According to our sign convention, behind the mirror is negative, so this DI is going to be negative 19 centimeters. If the height of the image is 7 centimeters, so HI is equal to 7 centimeters, where is the object located? So I want to find DO. And then it says, what is the magnification? So I'm going to find M. And is the image real or virtual? And is it upright or inverted? So I also want to find HO. So basically I have to find everything in this problem. So first we'll do it mathematically, and then we'll do it using array diagram to confirm our answers. All right, so where should we start? Well, I like to start with our basic equation. So 1 over F is equal to 1 over DI plus 1 over DO. Now, remember, yesterday we were solving for DI. Today we're solving for DO. So again, I want to rearrange my equation algebraically to solve for my unknown in terms of my known. So how do I do that? Well, first I say to myself, what am I solving for? I'm solving for DO. So I want to isolate that on one side of the equal sign all by itself. So 1 over F minus 1 over DI is equal to 1 over DO. Now I can't subtract these because they're fractions and they have a different denominator. Okay? So back in 5th grade we learned how to find a common denominator. So the common denominator between these, I'm going to have to multiply them, which would be DI times F. So I have DIF minus DIF. What do I put in the numerator? Well, to get DIF here, I'm multiplying top and bottom by DI. So I'm going to have DI here. Remember, DI over DI is 1. To get DIF here, I'm multiplying top and bottom by F, because F over F is 1. So DI over DIF minus F over DIF is equal to 1 over DO. Now I'm going to perform the subtraction. So I have DI minus F over DIF is equal to 1 over DO. Whenever I have fractions like this, to simplify, I'm going to cross multiply. There's no such rule as flip it. So DO times DI minus F is equal to DIF. And since I want to solve for DO, my final step is to divide this. So DO is equal to DIF over DI minus F. Now I can substitute in my values. So it's going to be negative 23 times, it's not 23, it's negative 19, negative 19 times negative 33 divided by negative 19 minus negative 33. Now this is where people are going to make their most common mistake. First of all, here, this is negative. A negative times a negative is a positive. So that's why it's important to show all these intermediate algebra steps so you don't make a mistake. So when you do all this mathematically, DO comes out to be 45 centimeters. Or is it 4.5? It's 44.7. Okay, so that's 45 centimeters. Because these have two significant figures, so this one would have two. All right. Now we use our other equation. Our other equation is HI over HO is equal to negative DI over DO. Yeah, so hi-ho, di-do, your Seven Dwarf song. Yeah, okay. So you remember this equation. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So I'm solving here for HO. Well, HO is in the denominator. So the first thing I would do is when I have something I want to solve for in the denominator, I'm going to cross multiply. So when I cross multiply, I have HIDO is equal to negative DI HO. And I want the HO to be by itself. So what I'm going to do is I'm going to divide by negative DI. So I'm going to have HIDO. Then here's my negative DI is equal to HO. So now I'm going to substitute in my values. So HO is equal to negative 7 times 45 divided by negative 19. So the negative in the numerator cancels with the negative in the denominator, so it comes about to be 16.57. So maybe on your answer sheet it says the answer 17. Yeah. So significant figures, this is going to be 17. When you take shortcuts and you plug numbers in your equation, you're going to mess up with the signs. I'm telling you that right now. So the question was, this is also equal to m, which is the magnification. What else do we have to solve? So when they say, what is my magnification is going to be, that's the next thing we have to find. So m is negative di over do. So m is going to be negative 19 over 45. So my magnification is going to be 0.42. And the magnification is really the negative times a negative is a positive. So how much larger or smaller than the original image? Like when you're looking, if you ever buy a small mirror to look in, they'll say the magnification of the mirror is, so that's what magnification is. So how do I know what this is? Well, this is virtual. How do I know that it's virtual? Because the DI is negative. It's upright. How do I know it's upright? Because the height is positive. So I know that it's virtual because DI is negative. I know that it's upright because H is positive. And that all has to do with my sign convention. That's why we need to be consistent with our sign convention and understand our sign convention. Sign convention is essential in anything that you do with physics. If you never establish a sign convention, you're never going to truly understand physics. All right, now we get to do the fun stuff. We get to do our ray diagram. So I'm going to take out a ruler. Maybe you have an agenda ruler. Maybe you don't. But that's what we're going to do right now. So when we do a ray diagram, first what we're going to do is we're going to draw a straight line to represent our principal axis. So here's our straight line. Then we're going to draw a vertical line to represent the mirror. Okay? And these are our two frames of reference. So it doesn't matter if we're doing, this is going to be the side where stuff is reflected off. So it doesn't matter if we're doing convex or concave. Remember, this is going to be positive, this is going to be negative, this is going to be positive, and this is going to be negative. So our sign convention is always going to be the same. Okay? So we have an object, and the object is a certain distance. Oh, this one they gave us DI was negative 19, and they gave us HI. So what we want to do is, well, this one already worked out, but you have to establish what is positive and negative. So again, this one, DI, they told us is negative 19. So what we're going to do for our sign convention is I'll just use that to be, like, I'm going to say 1 centimeter is 10, and I'm going to say 20 is, so when it says 19, I'm going to do here 1.9 or 19 millimeters. So that's where I'm going to put my image. And then they say that the image is 7 centimeters high, so I'll use the same sign convention. It's kind of tiny, and draw this as 7. Ugh. Let's see, that's going to be right there. Okay, so this is 7 like that. Okay. Then, now remember, you know the object is going to be on this point. Okay. So, that's all we really know. And what else do we know? We know we have to draw the focal point in the center of curvature. So they tell us that the focal point is 33. So, using this, you see how I'm going to do 3.3 with my ruler? So that's F. Now, if I know that F is 33, what is C? 66. So now with the ruler, I'm going to draw this here as 66. So that's F and this is C. So I can't do my ray diagrams unless I have C and F. Now, rule number 1 is that you go from the top of the object, you go parallel, and then you go through F. And this is from the top of the object. Then rule number 2 is you go parallel from the top of the object and then through F. And then the other one is back and forth through C. So let's say I was going to do rule number 1. I don't know where the object is, but I know that the object, rule number 1, when it hits the mirror, then it has to hit the top of the image and go through F. So what I'm going to do is, here's F, so I'm kind of doing it backwards. This is my virtual line here, watch. So I'm going to draw this one dashed. And then when I hit the mirror, this is the part where ray number 1 reflected off. And then where it came in was, it came in parallel, because remember, it's parallel and then through F. So it was ending up coming somewhere from here. Okay? And that was ray number 1. And then it bounced off. So that's ray 1. Okay? I'm going to do ray... Now, in the video, the lady who does it, and I suggest you watch those, ray number 3 is the easiest, because ray number 3 goes back and forth through C. So let's do that one because it's easy. So here's C. So C has to go through C and then through the top of the image. So now this part is dashed. When I hit the mirror, this is the part that reflects off, and that's back and forth, number 3. Now, where these objects meet, that's where this is actually where my object is, right there, where they crisscross. So that's where my original object was. Now, let me just show you something. So let me draw the object. Now remember, let's go back to how we learned rule number 1. From the top of the object, we went parallel and then back and forth through F. Rule number 3 was we go back and forth through C. So see how they crisscross there? So we're kind of doing the opposite. This was a difficult problem because it's the opposite. Usually they always give you the object, not the image. So this is probably the hardest ray diagram where you're kind of doing the opposite. How can I check my work? I can check my work by doing rule number 3, and hopefully I did it to scale. And rule number 3 should crisscross in that same place. I mean rule number 2. So rule number 2 was you go through, well, that's another way to do it, where rule number 2 was instead of going parallel through F, you go through F and then you go parallel. I think I'm going to have too many lines here and I don't want to confuse you. So anyway, using rule number 3 where you go back and forth through C, you see how that's the easiest one? So I would always do it this way also. So here is, this is rule number 3. Okay. So you see here's my object. And again, this is probably the most difficult, and I didn't realize on this one, I didn't remember from when I did the homework before, that they didn't tell you where the object was, because usually you start with the object and then you do it. Okay, so this one they gave us the image and we kind of had to work backwards. All right. You only have one other ray diagram you have to do for homework, number 6. So we did this both mathematically and using our ray diagram.